Okay, so now we're on to combined gas law. I know you're all very excited about this, much as I am very excited about this. Okay, combined gas law. So they're giving me 5 of the 6 pieces of information, and so I just have to put it in however I want. So I'm going to do P1 V1 T2 equals P1 V1 P2 V2 T1. There we go. Sometimes it's even hard for me to keep straight in my head. But there you go. P1 V1 T2 P2 V2 V1. So now I just have to look at the problem and identify each part. And I'm going to write this for each one of these. So 800 milliliters. So I have a volume 1. And at minus 23 degrees, so 273, so that's 253. So I have a T1 Kelvin. Let's make sure I keep this straight. Milliliters. And 300 torr, so I have a pressure 1, 300 torr. What would be the volume of the gas be at 227? So 227 plus 273 equals 227 plus 273 equals 500. So that's a T2, 500 degrees Kelvin. And a pressure of 600 torr, 600 torr. And so I'm solving for volume, V2, right? What would be the volume of gas? So 300 times 800 times 500, enter, divided by 600, enter, divided by 253, enter. It looks like I have 790. You should look closer at your calculator. 790.51 milliliters, which again, 800 milliliters, 790 milliliters. That's okay. I like that. That's a pretty good answer. So we're going to run with that. 790.51 milliliters. Okay, number 2. And I'm going to spread these out this time so I can identify very clearly. P1 V1 T2 equals you see I'm scattered today. What's going on? P1 V1 T2 P2 V2 T1. All right, 500 liters. I'm going to use that as my volume 1. 700 millimeters of mercury. That's the pressure. 700 millimeters of mercury. 200 degrees Celsius. So that's 473. That's my T1. Gas gets placed into a tank under high pressure. When the tank cools to 20, 273 plus 20 is 293. So that looks like that's my T2. The pressure of the gas is 30 atmospheres. Oh, we have a problem, Houston. 30 atmospheres. I can't use atmospheres on this side and mercury on this side, so I have to do a conversion. So I'm going to go ahead and convert these ATMs to this mercury. Okay. Remember this guy? Dimensional analysis. I have 30 ATMs. And I know that for every 1 ATM, I have 760 millimeters of mercury. So 30 times 760 is 22,800. 22,800 millimeters of mercury, which seems like an exorbitant number, but you're talking about 30 atmospheres here. So it's not that crazy. So now I got to get rid of this atmospheres, add in these 22,800 millimeters of mercury, And so it looks like for number 2, we are looking for, what is the volume of gas? The volume. Okay. 700 times 500 times 293, enter, divided by, and I'm going to do parentheses this time and do 22,800 times 473. So I have X equals 9.50 liters. So when I cooled this thing off from 200 degrees, I went from 500 liters to 9.5 liters. And while this answer doesn't look hugely, 9.5 is nowhere near 500, right? But you got to understand, I went from 700 millimeters of mercury to 22,800, which is only realistic if you're on another planet or I'm pressurizing a tank or something like that. Anyway, I don't like non-real world questions, but the show must go on. So number 3. Number 2. You like how I've changed up how I'm numbering here? Like parentheses, and now we'll do number. I think the next one I'll do 4 dot. Okay, 3. What do we got? Okay, and again, I'm going to do the same thing. This just helps me keep straight in my head. P2, V2, T1. All right, 2 liters of hydrogen originally at 25 degrees. So I have 2 liters. I have a volume, 2 liters. Originally at 25, so T1 is 298 Kelvin. And 750 millimeters of mercury. So I have a pressure, 750 millimeters of mercury. Okay. Are heated until a volume of 20 liters. So I have a volume of 20 liters over here. And a pressure of 3.5 atmospheres. They've done it to me again. They've given me 3.5 atmospheres. So I have to convert 3.5 atmospheres times 760 millimeters of mercury, and I can ignore the 1 ATM. Anything you divide by 1 is going to be the same thing. So 3.5 times 760 equals 2,660. 2,660 millimeters of mercury. And they're asking me, what is the new temperature? So what is T2? All right, 2,660 times 20 liters times 298 degrees, enter, divided by 2 divided by 750 equals a ridiculous number. That cannot be right. 2,660 times 20 times 298 equals, that is a huge number, divided by 2 times. Yep, no way around it. X equals 10,569 degrees Kelvin. Yeah, so in order to make the pressure go that much higher, yeah, I'm going to have to increase the temp by that much. I hate non-real world questions, but, you know, whatever. 10,569 degrees Kelvin. Yeah, probably like the sun. Okay. So let's look at 4 here. Okay. P1, V1, T2 equals P2, V2, T1. Number 4, a gas is heated from 263 degrees Kelvin. Temp 1 is 263 degrees Kelvin. to 298 Kelvin. Temp 2 is 298 degrees Kelvin. And the volume is increased from 24 liters. Volume was originally 24 liters to 35 liters. 35 liters. If the original pressure was 1 atmosphere, 1 atm. All right, looks like we're solving for a pressure. 1 times 24 times 298, enter, divided by 35, divided by 263, enter. It looks like I have 0.776 atmospheres. X equals, and 1 atmosphere, 0.776. I like this better than the last one, so 0.776 atmospheres. All right. Oh, man. Okay, well, we'll get back to it after I have class.